Exam review question related to constitutional isomerism. Use as many of the boxes as you need to draw the line angle structures of all constitutional isomers of primary alcohols having the molecular formula C6H14O. Below each structure, write its correct IUPAC name. Ignore stereochemistry. Okay, let's get into it. So, in order to tackle constitutional isomerism questions, we need to be really systematic with our approach. So we know that we have a 6-carbon compound, but we can only have primary alcohols. Now remember, primary alcohols is always in reference to the carbon atom in which the alcohol is bound. So for instance, if I draw a primary butanol, it would look something like this, because this carbon, which is directly bound to the alcohol, is primary. It is only bound to one other carbon right here. So primary alcohols are always in reference to the carbon atom in which they are bound. It's the same thing with halides as well. So having said that, let's draw out the obvious structure, which would be 1-hexanol. We draw in 6 carbon atoms in our chain and put the OH towards the end. The way to name this compound would be 1-hexanol, or we can also write hexan-1-ol. Now, what worked best for me when I did isomerism questions was I drew out the most simple structure, which in this case is 1-hexanol, and then I used that as a template for further structures. So the key is to sort of exhaust all your options. So you start with the longest carbon chain, which in this case would be 6 carbons, and you find all the isomers with a 6-carbon chain. Then you can move to a 5-carbon chain, and then you move to 4 carbons and so on. The key is just to be systematic with the approach. So in fact, there's no other structure with 6 carbons, so now we move on to a 5-carbon structure. Remember, the alcohol always remains primary. Here I can start by putting the methyl group on carbon 4. And the way to properly name this according to IUPAC is 4-methyl-1-pentanol. We can also move this methyl group around, so even though it is bound to carbon 4, we can move it to 3, and then we can move it to 2, so we can draw those structures out as well. So in essence, we have a 3-methyl-pentanol and a 2-methyl-1-pentanol, both of which are obviously primary. So these are the 4 compounds we have so far. We started with a 6-carbon compound, and simply it's normal hexanol, 1-hexanol, and we use that as a template by subsequently moving the methyl group on a pentanol from 4 to 3 to 2, and we got these structures here. So before we move on to 4-carbon compounds, just note that we can't exhaust the 5-carbon compounds anymore, because if I move this methyl group right here onto carbon 1, the alcohol won't be primary anymore, and that violates the instructions of the question. So if we take a look at doing that just as a thought experiment and placing the methyl group here, well, the alcohol is bound to a secondary carbon in which there are 2 carbons bound to it. So that would violate the rules. So there are quite a few 4-carbon compounds, and let's go through all of them. So let's start out by ensuring the alcohol is primary, and we attach it to the 1 position, and we draw out our 4-carbon chain. Once we have that, we must add in 2 more methyl groups, or perhaps 1 ethyl group, to satisfy the molecular formula C6H14O. So we can start out by putting a methyl group right here and right here. So that satisfies the molecular formula. The way to name this compound would be 2,3-dimethyl-1-butanol. Now similarly, we can move these methyls around just like we did here. I can take this methyl group here and attach it to carbon 3, forming a quaternary carbon, even though we keep the alcohol primary. So again, always ensure the alcohol is primary. We draw that out first. We draw out our carbon chain here, and we put 2 methyl groups here. The way to name this compound would be 3,3-dimethyl 1-butanol. And for the next structure, it is viable to move these 2 methyl groups onto carbon 2, so we can essentially move that quaternary carbon from 3 to 2. And the structure would thus be 2,2-dimethyl 1-butanol instead of 3,3. So in order to draw out the structure, remember, always maintain the alcohol as primary, and we put in our methyl groups here on carbon 2, and the way to name this is 2,2-dimethyl 1-butanol. So we have 7 structures, and this is really where I would get stuck because I never enjoyed these questions, and even though I was systematic, I always seemed to be missing one structure. We moved around all these methyl groups here. We exhausted 6 carbon, 5 carbon, and 4 carbon chains, and it seems like we have 7 structures. Well, I had to really think this through, but we can use ethyl groups as well as methyl groups. So what does that mean? Well, again, we keep the alcohol primary here. We can draw out our 4 carbon chain, and we can attach an ethyl group, let's say right here. That would be a viable structure. The way to name this would be 2-ethyl 1-butanol. So these are all 8 structures for C6H14O. Remember, when you tackle these problems on the exam, start with the longest carbon chain and then gradually move down.